Hello, Chem 1A. This is Chapter 6, Lecture Video 1, and this chapter is about thermodynamics. And so thermodynamics is primarily about heat and the transfer of heat and how that occurs in chemical reactions and other processes. So explosions are a great example of an exothermic process, and we'll get into that as we go through this chapter. All right, so uh, the law of conservation of energy is the clearest place to start. And it basically states, just like the law of conservation of mass, that energy is conserved. It can be converted from one form to another, but we cannot create or destroy it. So the total energy in the universe is constant. Now, if any of you finds a way to disprove this law, don't tell anybody. Not a big deal. Just email me everything you have about your findings. And then when I become the richest person on the planet, it's completely unrelated. Don't worry about it. If you're able to, for instance, form energy from nothing, that would be a pretty big deal in terms of the electricity companies out there. It won't happen. This is a well-tested law. Now, but if it does, just tell me about it. Don't tell anybody else. So the form of energy typically used that we talk about in chemistry is thermal energy. This is due to heat transfer. It's typically the energy due to particulate motion, vibrations, what have you. So one of the things that we need to understand before we move too far into the content of this chapter is the differences between heat and temperature. So heat is actually the movement of energy from something, an object or substance that is hotter, to an object or substance that is colder. Whereas temperature is actually the measure of the intensity of the heat and not the amount. This is a very important distinction. So a great analogy for this is the difference between a drop of boiling water versus a pot of boiling water. Now, for instance, let's say we have a pot and it has a bunch of water and that water is boiling, right? Versus, a single drop from like maybe a medicine dropper. This drop is at 100 degrees Celsius if it's boiling. And all this water is also at 100 degrees Celsius when boiling, at least at sea level. Now, let's think about a hand, right? Let's say you have, my horrible artistic drawing. You have your hand, and that drop of boiling water touches your hand. It's going to hurt a little bit, right? What if we put our hand in there? It's going to hurt a lot more, right? Why? They're both at the same temperature. A drop of boiling water is not going to hurt your skin nearly as much as putting your hand in a bucket of boiling water. And the major difference between these two things is while the bucket or the pot of boiling water and the drop are at the same temperature, they have vastly different amounts of heat or energy present. The pot has a lot more energy in there because there's more water at that temperature. Whereas the drop has a tiny amount of energy because it's only one tiny amount of water at that temperature. And this is a very big difference. So the major difference between these two is if we have a drop or a pot of boiling water, they're both going to be at the same temperature, but the amount of heat present in them is dramatically different. Okay, so let's talk about where energy goes to and from, right? So system and surroundings are two very important aspects of chemistry and really thermodynamics, the study of thermodynamics that we need to understand. So system is really just what we say is the part of the universe we are studying. for instance, the contents of a beaker or a reaction. It's the thing we're interested in. Whereas the surroundings are going to be everything else, right? So if we're studying the inside of a beaker, the glass of the beaker would be part of the surroundings. The air above the beaker, the air in the room the beaker's in, the walls of the room, the ceiling, the building, the air outside the building. You get the idea. Everything else is part of the surroundings. You, in that example, would be part of the surroundings. All right, so these two we'll talk a lot more about in the next lecture video. As always, if you have any questions, please don't hesitate to email me or come to office hours.